folks, welcome to Mondays with Neil. I am Neil Thornton. I've been teaching for Manhattan Prep for I think 8-9 years now. I started teaching GRE classes for the very first time in 1993 when I was still an undergrad. And actually, no, I just graduated, but teaching SAT, GRE, GMAT for 20 some years. I love the GRE. I think it's a fascinating test. I love cracking the GRE. I love doing well, and I like teaching this. So a free prep hour, what are we up to? Well, free prep hour is our moment as teachers to kind of nerd out or geek out on one particular aspect of the GRE. Sometimes we give you global strategies. Sometimes we dig into something specific like we're doing today. So today's agenda is going to be percents on the GRE. Why percents on the GRE? Well, I'm a big adherent of the 80-20 principle, the principle that 80% of your effort should go, 20%, yeah, all of your effort should go to the thing that is most likely to show up on the GRE. Percents are probably the most common thing tested on the GRE. They are trickier than what they are in the real world. So I'm going to show you some of the traps that the GRE lays out. And if you have a solid foundation, basics of percents, you can then apply those to really difficult and challenging percent problems. And the sky's the limit, and you have a really solid foundation on which to sit. Even if you might be a financial accountant right now, how percents are tested on the GRE may be peculiar to you. So I'm going to throw some new tools and techniques your way, ways of thinking about percentages that might be better on testing when you're getting tricked and trapped into thinking things are slightly different. So that's what we're doing, and that's why we're doing it. So percents is not a lot of effort. It's something you're familiar with. You shop every day, you pay taxes, you do profit and loss statements. So it's something you're familiar with. So on the 80-20 principle, it's basically 20% effort. It's not a lot of effort for something that has 80% results. It's going to have big, massive results, and it allows you to move faster and quicker and avoid all the traps that might be on the GRE. So that's our job for today. And that's what we're going to spend most of the rest of the hour on. So get ready, take notes. Again, give me objections, give me questions, give me different ways of thinking about things, and we are ready to go. So here we go. All right. Real basics are, the first thing I want to give you is a new tool for handling questions that are here on the screen. Questions like 30% of what percent of 200 is 48. Now, you can think about these things. You can work these things out, bite-sized pieces, but on the GRE, one of our major questions we have whenever we're faced with a word problem is, oh God, how do I set this up? How do I make this into algebra? All right, so what I want to do is take sentences like this whenever they appear on the GRE and translate these into simple algebra without much thinking, without much effort, without much strife. So this is where we're going to go, and then we're going to play with some other things too along the way. So here we go, 30%. So we're going to go left to right, and what I'm really interested in is getting you all to begin to, understand what these words mean and how to get them on your scratch paper when they appear on the GRE. So question number one is, what does the word percent mean? Translation-wise or algebraically? What do you think? So those watching the recording, I'm going to recite some of the things that appear in the chat window. So get the chat window going and start typing in the chat window. What does the word percent actually mean? All right, so Jessica is telling me percent means a portion. A percent means a fraction. Yes, all right, great, I'm with you. All right, a portion, a fraction, and then 46245, and Edgar say per 100. Excellent. So a percent is a way of expressing a fraction, a part of something. So if I have, for instance, a pencil, I could talk about half the length, a third of the length, 3/4 of the length, 5/8 of the length, or I could talk about 50% of the length, 75% of the length, 100% of the length, 83.5% or 0.17% of the length of the pencil. All right, so we're talking about a fraction, a proportion out of 100. So and we're gonna do a little game with this in a minute. On the GRE, whenever I see the word percent or whenever I see a percent symbol on the screen, what goes on my scratch paper is divided by 100. All right. So we'll talk about setting this up in a nice, clean, pretty way, but if I see the word percent or if I see the percent symbol, I'm going to write divided by 100. If I say 3/4 of something or half of something, or let's say I had the word half of 8. If I started translating this, what is half of 8 anyway? Dumb question. All right. So what do I do with a half and 8? Mathematically, what does of mean? All right, so if I do divide or multiply, all right, cool. So Jessica, you've got a point. I'm taking 8 and I'm dividing it by 2. Jessica says divide, and you're right, I'm dividing 8 by 2. But in this case, I've already got the divided by 2 part in that. So I've got a half. So if what do I want to do with a half and 8 is I want to multiply. So if I have a half times 8, well, I'm doing 1 times 8 over 2, and this is how I'm getting my 4. So when I see of on the GRE, I'm going to think multiply. Now, this works with fraction problems too. If I have 3/8 of 24, I'm going to go 3/8 times 24. If I have 5/8 of 56, I'll go 5/8 times 56. I use a dot for of so I don't confuse it with variables. So what about the word what? What's our mathematical expression for a what, for an unknown? X, okay. So a variable, X is fine. I don't always like X because I confuse that sometimes with multiplication symbols. Also, there might already be an X in there. So give me another variable I could use besides X. I could use X. Okay, I could use a Z. I could use an R. I could use a Q. I can use a P. I can use an N. I can use an M. I can use any other letter besides X, but a variable is fine. I can use X. X's are fine. But I watch a lot of people get into trouble when there's already an X in the problem and they see a what and they add another X and now I got 2 X's and I don't know which one means what. So just be cautious about that, and you can use any variable you want to. All right, so what is an unknown, and we're going to pop in a variable. Sweet. All right. So 30% of what percent? I've got a percent, I've got an of. What about an is? What do you think equal sign. Wonderful. Great. So we're going to use that. So in our chat window, we've said, okay, that an is an equal sign. Great. Now, I'm going to give you a task. We're going to take this expression here, this sentence, 30% of what percent of 200 is 48. And I want you to try in the chat window as cleanly as possible to translate this into an algebraic expression. Now, here's the key. The way to make this work is go left to right, word by word, translate each of these things one at a time, and don't miss anything along the way. So make sure you get every last bit of this 1, 2, 3, 4, 5 as a time. So try it in the chat window and start turning this into algebra. If you see percent, make it divided by 100. If you see of, make it multiply. If you see what, make it a variable. If you say is, make it an equal sign. Taylor, awesome. Gianna, awesome. And Perez, awesome. Damaris, awesome. Great. Rachel, We missed a couple words there, so I want to make sure that you have caught all of the words there and you hit all of those left to right. So give it another shot, Rachel. This is a tricky game to play the very first time. So I usually take my finger on the screen and I go, okay, I'm going to touch that word, and then I'm going to touch that word, I'm going to touch that word, I'm going to touch that word, and I'm going to touch that word. All right. 4625, you missed a word there. So make sure you get all the words. You missed one word out of this. So let's check where we are here. Yeah. Cool. All right. So I'm taking this English and I want to hit it left to right. All your parentheticals are great. Don't sweat parentheticals too hard of like using parentheses. So I'm going to see if I can't do this using my mouse and talk about how I'm going to set this up on a scratch paper. All right. So I have 30. And the next word is percent. So I'm going to take this and drop percent on my scratch paper. The next word over, so I've typed 30, and then I did percent. The next word over is of, so we're going to hit multiply. Now here's the tricky part. Some of you got it, some of you missed it. No harm, no foul, but pay attention to the words that here. We don't just have what, but we have what percent. So do me a favor, everyone, translate that what percent part. What would I put there? Ah, okay, sweet. So I got a what percent. Nice. Now on my scratch paper, I'm going to talk, oh, Tiara, make sure you translate that percent. Don't just write the percent down, make it into math. So it says what percent, but if I want to make it a manipulatable math, I want to go per 100. All right, now of 200, just for convenience sakes, on my scratch paper, I'm going to be kind of cautious about floating that 200 up. If that's a whole number, I want to pop that on the top of a fraction bar. And even as a nice placeholder, I might just drop over 1. So I've got 30% of X percent of 200 over 1 is, and again, that 48 is a nice whole number. I'm going to float that above and maybe even drop this below. All right. So with a little practice, this takes 5 seconds. You see this on the screen and you go, okay, 30 over 100 times X over 100 times 200 equals 48. And as if I'm clean and neat on my scratch paper, now I'm ready for the next phase. Nice. So time saver, left to right. Brain saver, don't miss any words. Time saver a little bit later, set it up neatly enough so that you can be relatively convenient about what do you think any next step might be. I've got this on my scratch paper. What is a way to make this? Ah, Gianna, beautiful. I'm making me so happy. Gianna said simplify. All right. So I want to pay attention to one side of this and find any opportunity I have to knock off any redundancies over here, to simplify and reduce this as much as possible. What are some things I might be able to simplify out of this? Yeah, okay. So yeah, the 30 and 100. So what I want to start doing first is start losing zeros. So on that 30 of 100, notice how I've got one extra 0 here. So I divided 1 by 10 and another by 10. And then Perez says, hey, I can reduce that 200 and that 100. Awesome. I've got 2 zeros up here and 2 zeros down here. Now, before you move on, quick little careless error check. Make sure that I've crossed off the same number on top as I have on the bottom. So I got 1, 2, 3 crossed off on top, 1, 2, 3 crossed off on the bottom. I'm good. If you have 4 on top and 3 on the bottom, you made a mistake. Be careful about that. All right, so let's condense the top. I got a 3 and an X and a 2. What do you end up with when you multiply all those together? Great, I got a 6X. And down below, when I multiply a 10, a 1, and a 1, what do I get? All right, 10. All right, now I got a nice little 48 over 1. All right, now I could keep reducing The 6 and the 10, that's fine. Just a little time shaver, a little shortcut, get a second off of this. I would rather multiply by 48 by 10 than by 5. 48 times 5, I have to think or pop up my calculator, so I don't want to do that. 48 times 10 is super easy, so I'm going to stop there, and I get 6x equals, let's multiply both sides by 10, 480. What's our x turn into? All right, 48 divided by 6 is 80. Nice. All right, so know your times tables. If you're taking the GRE in like a month or so, just start jamming. Find a little iPhone app where you're testing your times tables. 48, 6 times 8 is 48, 48 divided by 6. So 80. And the answer here is going to be, you know, the what is 80. And so other people added a percent back on that. That's fine. But your answer here is ultimately 80. So what percent? 80. Nice. Questions about that process? Thoughts about the thumbs up, thumbs down? Kind of cool. Not every time, all the time, Gianna, but this is when I get stuff that looks like this. This is one of the tools I have available to me. So let's go, and I'm going to pop a few pages ahead here. And so the game here is Gianna asked, hey, do you do this every time? One of the things we're going to play with in the next hour is this a percent of question, or is this a percent increase decrease question? So notice this is a percent of, so it's all ofs and ises, and there's no increases and decreases. So this is a big indication that, yes, I'm probably going to do this on especially these really complicated ones where it's all of kind of stuff. So let's look at this. What are problems here that are merely percentage of problems? So we, oh, by the way, just to give you a reference of where we're working out of, we're working out of the 5-pound book of practice problems. Big old thick book. You don't have to do every problem, but what I do is I take a diagnostic test. I figure out my weakest areas, and then I jam this book until I don't have a weak area anymore. And so on and so forth. It's a really killer book. It really works great in tandem with a practice test. You take a practice test and you go, oh crap, I need to fix inequalities. And then you go back here and you fix inequalities. And then you go on to the next thing. And you're, okay, after inequalities, I need to fix standard deviation percent, whatever. So it's a really killer book. But if you look at it and you start from question number 1 and work your way forward, oh my God, isn't it intimidating? So it's just a great resource of stuff. So we're going to play out of that today. And again, so tell me, out of these problems, which of these kind of lend themselves to this approach? And this is percent of, but not percent increase. Yeah, so 8, 9, and 10 are just flat out brilliant translation opportunities. So I don't have to think, all I have to do is translate these. So let's try these as a collective and see what we can get out of here. So in your chat window, left to right, translate number 8 into an algebraic expression. We don't even need to solve these so much as we need to just get into the habit. So let's try number 8. 12 is 5% of what number? So nice, Emma got it. All right, so 12 is 5% of what number? Nice. All right, now I can multiply. I could reduce down this side. We can simplify that to 1 over 20. Multiply both sides by 20 now, and I could x equals 240. Yes, a lot of you absolutely could think, or yeah, so of what numbers, yeah, so not what percent. Good catch, Damaris. So people watching the recording, somebody said 12 equals 5% of z percent. Oh, I added an extra percent and you caught it. Good catch. I like a good catch, man. Yeah, so in this case, cool. I don't have to think. I can just use my mechanics. I could think my way around this. There is a way of checking things in your head. You can call it benchmarking, or you can call it an exact percentages method. I call it something my mom taught me when we were learning tips. So let's go on a little alternative journey off to the side here, because that's what this class is all about. Let's say you go buy dinner somewhere and the tab comes out to be, oh, let's just call it a nice even 80 bucks. All right. So you're going out to dinner somewhere and the bill comes and it's a nice even 80 bucks. What I want to get you in the habit of doing every time you see any money change hands at all is starting to estimate and calculate in your head what might be going on with tips, what might be going on with taxes, what might be going on with discounts, for instance. So let's take $80 and let's start playing around with 80 bucks here. All right. So 80 bucks, my first question on any amount of money handed to me or otherwise is just what's a flat out 10% of 80? Yeah, 8. Okay, so you're just popping a decimal place over, and I know 10% is 80. All right. So 10% of 80 bucks is $8. So this is me having fun with, so let me pop that with text. All right. Once I have that in my head, then almost everything else I need as information and to be able to calculate stuff in my head is available to me. So if 10% is 8, what's 20%? Is 16. Great. If 10% is 8, go back to 10%. What is 5%? Okay, so 5% equals 4. All right, cool. So 5% would be 4. And so therefore, everything else we need, if you know your 50% and your 25%, that also helps. What would 1% be of 80? Cool, 0.8. So from here, if I've got those benchmarks, as I call it, let's do, what would a nice, or not nice, what would a very flat, basics, modern level of, base level humanity 15% tip be? If 10% is 8 and 5% is 4, what would a 15% tip on this tab be? Cool, 12 bucks. Take your 10%, 8, have it, you get 4. So cool, what would a 20% tip be? That would be 16 bucks. Nice. So sweet. What if you had, what would, not just what the answer is, but what would you do if you were being taxed at 9%? What would you do here? Cool. So N Perez says take 10%, which is $8, subtract 1%, which is 0.8. So what is 10% minus 1% of this $80 tab? Cool. All right. So 7.2. So 10%. So 8 minus 0.8 equals 7.2. What's another way of using these benchmarks to figure out what a 9% would be? Either 10% minus 1, or what can I do to 1%? Oh yeah, so 5 plus 1 plus 1 plus 1, I can do it additive to get a 9%. So 4 plus 0.8 times 4 plus 3 times 3. Cool, I love that idea. Or I could do 1%, 0.8 times 9. 8 times 9 is 72. Move a decimal place, I get 7.2. So there's a lot of different ways of doing stuff in your head. The problem is under... no, not necessarily. I'm just kind of going off to the side. What I want to do here is I want to do things mechanically, because under the stress of test day, I want both a mental method and a kind of a mechanical method to meet in the middle. Because under the stress of test day, I might even make careless errors in the mechanical method. I'm definitely going to make careless errors if I do this in my head. So I just want to make sure they kind of meet in the middle. And if they don't jive, I'm going to try to figure out what's going on here. So 12 is 5% of what number? Well, if 12 is 5%, then 24 would be 10%. So 24 is 10% of 240. Okay, cool. I've got to double check on that. So it could be a check for number 9. 7% of 9 is what percent of 7? Fine. But I just want to give you some other things that might happen in your head. Like if you screw up a decimal place and you get a number, if you're taking 10% of something and you screw up a decimal place and you get a number bigger than what you were expecting, cool. All right. Number 9, translate. Back to translation. Let's translate number 9. We don't have to solve it, but we can flat out translate it left to right. 7% of 9 is what percent of 7? Okay, cool. So great. And as long as you got all the percents in there, make sure you got all the percents in there and all the numbers in there. 7% of 9 is what percent of 7? Let's multiply both sides by 100 here just to knock out those hundreds. And then I got 7 times 9 is x times 7. Oh, sweet. X equals 9 if I divide both sides by 7. So my brain explodes when I read that. If I read that, I go 7% of 9 is what percent of 7? I'm like, oh, there's a trick. Set it up and you can see it. All right, cool. Number 10, let's just set it up. Give me a nice translation. All right, what percent of 13 is? So cool, so we just take that left to right, and number 10, we get what percent of 13 is 20% of 195. Great, okay. Wonderful. Solve it on your own. Have fun. We don't need to go over algebra. All we need to do is just make sure you've got it set up well. And got some other tools out there for you. Cool. All right. Now, 2 things happen on the GRE. Sometimes these test writers are asking you all about percent of, portions of, percent of. One of the biggest traps and on GRE is missing when they're not asking percent of, but instead they're asking percent more or percent less in various forms. So other words for more I've seen on the GRE include increase, profit, percent increase, percent greater. So I want to keep an eye out for this. So right before I launch into any GRE percent problem, I want to think, okay, is this an of problem or is this an increase or a more? So I've seen percent increase, percent more, percent greater. I've seen percent less. I've seen percent decrease. I've seen percent discount. I've seen less or loss as opposed to profit, a discount, a profit, a less, or a loss. So weird little exercise. I'm going to go to this next page and let's go one at a time and just tell me, is this a percent of problem? We don't have to solve it, we don't have to do it, but just tell me, is it a percent of problem or is it a percent change problem? All right, and that's all I need to know about these. So number 12, is this of or is this change? All right, that's a nice of. What about 13? Great, change. What about number 14? Ah, nice, reduced by. All right, what about number 15? Nice, okay. So this is a mental check I have before I start jamming on any problem. Is this an of or is this a change problem? We're going to talk about how to handle percent changes here in a moment, but really important check here. So let's go over these next ones. The next batch out of here. Number 16, is this an of problem or a change problem? All right, it's a nice of. What about 17? It's a change problem. Cool. What about number 18? Nice. Of. Cool. And what about number 19? Cool. All right. Nailing it. Well done. Really well done. Excellent. So have that moment before you launch into anything. So I'm going to go to a blank slide here, and I just want to talk about of versus change versus loss, and what are some of the things I like to picture, and then we're going to get into some actual mechanics of this. So let's take a brick, for instance, and I'm just going to draw a big brick here, and I'm going to call this brick 80. It could be 80 bucks. It could be, actually, let's change the number up a little bit. So I'm going to take this brick here and we're going to call it 60. All right, that could be 60 bucks or 60 ounces or 60 inches or 60 millimeters, any 60 anything. So brick of 60, choose your unit, $60 or something like that. All right, so let's play around with what we see and what do we see here, and then so let's play around then with 30%. What is 30% of 60? Any method you want. 30% of 60. Nice. Okay, flat out 18. Okay, so 10% of 6 times 3 is 18, or I could write it out, 30% of 60, knock off a couple zeros, I got 18, whichever occurs to me first. You got both methods. You got it in your head, you got it on paper, or in your calculator, of course, not a big fan, 0.30 times 6, all right, 0.3 times 6, 0 equals 18. Cool. Now, what do I have pictured here? Well, if I take here 30% of 60, I'm talking about almost kind of about a third of that chunk. So let's take that. And so that's what I have pictured, is this knocking off a chunk of this chocolate bar to say, hey, there's my 30%, about a third as much. So yeah, that's what a third looks like to me. So I'm going to put that over here. So that's what 30% of 60 looks like. What would a 30% increase look like? And what would the actual number be? A 30% increase. Great. So what are we doing with an increase is we are going to be taking that original 60 here, whatever that looked like, and we're going to be tacking that little brick right on top of it. So not to scale, but now I'm adding that 16 on top of the 60. All right, so I picture what is it of, but then for an increase, I'm going to be adding that amount. So if I said a 30% increase or 30% more than 60, we're going to take that 60, find 30%, there's 18, add it on top, so 60 plus 18 is 78. All right, smiley faces, frowny faces, yeses or nos, are we good so far? I know it's a little basic, but oh my God, if you get this, wow, GRE is faster. Okay, cool. All right. What about a 30% less than 60. What do you think you got there? Nice. Okay. Really well done. We're taking that 30% and we're just chopping it right off the top. All right. So 30% less than 60. Let me drop this here. Less than 60 is whatever 60 minus 18 is. So that would be 42. Brilliant. Okay. So that's our thought process. So when I think more, I chop it and I duplicate it up top. When I think less, I chop it and I chuck that part away. Cool. Lots of fun. We can, as long as we got the thought process down, we can start playing around a little bit of what would happen in your calculator. So let's talk about what would happen in your calculator. We got 30% of 60, and as a translation, fine, no big deal. And then we'll talk about some calculations here, how to set this up, and what would I put on my scratch paper. What would you pop into your calculator to just calculate 30% of 60? Let's do this, just pop, pop, pop calculator. All right, cool. So 0.30 times 60 equals. So there's a nice translation, or 30 out of 100 and reduced down, right? So that's your calculator thing. What do you think about 30% more than 60? Those of you who work in Excel, what goes in your Excel spreadsheet? Yes, awesome. Okay, so 1.30 times 60. So that 1 is the original. The 0.3 is that 30%. So we're taking the original, the one block of 60, and we're taking 30% and we're adding on. So 1.30 times 60. What about your translation of 30% less than 60? So more than was 1.3. Yes, Monica, Patrice, everybody, great. So what we're doing, I'll do it in the long way, 1 minus 0.3, also known as 0.7 times that 60 equals. All right, so you take, so a little bit of a, now we're moving into understanding first, now a little bit of a shortcut. If you need to calculate a 30% increase, okay, 1.3. 30% decrease, 0.7. It's a little harder to wrap your brain around, but we're talking 0.7 as in 30% more, 1 plus, 30% less, 1 minus. Smiley faces, thumbs up, yes, no. I see a smiley face, I see a yes. It's your class too. If you're a little lost, let me know. You can send me a private chat. We should be cool. All right. So let's go and talk about now, if I have a percent change question, there's one of two things that happens. I may just be able to flat out translate this. So let's try to do some translations of these into, based on what we just did over to the right, let's see if we can't get this on this page, this exercise here. And then there's more to do. 20% of X, what would you put on your paper as sort of an algebraic translation of that? Using decimals, using fractions, using anything. All right. Wow, you learned a thing and you're applying it. Great, I love it. So some of you were doing 20% of X. 20% times X, nice. That doesn't look so great in, I like the way you actually separated that out. Doesn't look so great line to line. What would I do? Let's change, I'll go 20, well above 100. And then times X. I might float that X a little bit so I make sure that goes part of the whole number. Also known as 1/5 of X or X divided by 5. What's the decimal calculator Excel version of that? Yeah, cool, 0.2X. All is well, all is good. All right, so 0.2X. Whatever you want to do there, we're solid. Okay, now let's run through it. Decimal version. What is the decimal version of 20% more than x? Cool, 1.2x. What is the fraction version of 20% more than x? Let's stay on 20% more than x. Aha, 120% times x. Well done. All right. So I added an extra x there. Fine. Cool. All right, so 120% of x. What about 20% less than x? Some of you are ahead of me. Decimal version? Marta, no problem. I like people chomping at the bit. Let's go. Excellent. All right. 0.8 x. What about a fraction version? Nice, Alex. Well done. 80% of x. Cool. Well, what does 80% reduce down to? Yeah, so n per s, great. What you just put there, 1 minus 20% of x. So just skip right to 80%. So 100% minus 20% is 80%, and you can save a lot of pen strokes. Thumbs up? Does that make sense to you? So 1 minus 20%, fine. What's a reduced version of 80%? Reduce that fraction down. Ooh, careful there, Patrice. That's 40%. There we go. All right, 4/5 of x. Cool. All right. Okay. So these are where the GRE starts to mess with us a little bit. What do you think 100% more than x would be? Cool. Nice. So what we're talking is, we're 100% of x is 1x. So we're talking x plus 100% of x, also known as x. So we're doing 1 and. Keep that in mind for the next one. What do you think the translation of 300% more than x is? Yes! Yes, awesome. That's the first time like a whole string of people have gotten it right. Yes, awesome. It's all about getting that visualization. Is you got your original, now I'm adding 300%. Thousands of people before this moment have said 3x, even after going through all of that. So everyone said 4x. Excellent, 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 excellent. All right. Why 4x? All right, so we got our x plus that 300%, and ultimately we're leading to 4x. Woohoo! Yes, wonderful. So as long as the visualization of taking your original, adding a chunk, or taking your original and taking away a chunk, 300% of is way different from 300% more. So some methodological things. Ooh, percent problem. Love percent problems. Good at those. Is this a change or is this an of? If it's a change, I want to think 1 and or 1 minus. So 1 and 20%, 1 minus 20%, 1 and 100%, 1 and 300%, and so on. Well done. Very good. So that's that. That's thinking. But sometimes they're not giving us the percent. All this page, they gave us the percent. Sometimes they ask us to calculate what the percent is. 8 is what percent more than 6. 6 is what percent less than 8. All right, so this is, they're asking us the percent, and this is a third technique and that I kind of want to keep on my back, keep in my backpack, keep in my toolkit, just in case something else comes out for me. All right, so let's get the visualization of this. 8 is what percent more than 6. So let's take a look at that first one. And my first question when I'm faced with one of these is I'm going from what to what? From what to what? On that very first question where 8 is what percent more than 6, where are we starting? Where are we going? I want to think about that. All right, the order we've given is 8 is what percent more than 6. So I'm getting 6 to 8 and 8 to 6. So let's just focus on that very first question here and let's think about it. What's our original amount that we are then increasing or decreasing? Are we going from 8 to 6 or 6 to 8? What do you think? I'll give you another way of thinking about this, but vote again. I've gotten multiple answers. And still 8 to 6. Okay. One of the things to do when I see more faced with is I see 8 than 6. I'm like, I'm going from 8 to 6 to 6 to 8. Shit, it's the GRE. I'm never going to go. All right, you get all this, they're really anxious about this, and it's really easy to flip around. So let's think about this. If we're talking more, draw an arrow up. If you're thinking more, draw an arrow up, and then I can go, oh, here's my little picture of 6, and then I'm going to my big picture of 8. All right, so from 6 to 8. Cool. Now think about that. Let's think about that visualization we had. If we're starting from 6, more than 6 is this big thing 8. So I draw that little arrow up and I can decide which way I'm going. Why do they tell me? Because they said more. Think about that visualization. If we had our original, we took a chunk of it and we glued it on top. Give me an estimation. Marta says 30%. Give me some guesses as to what percentages we're talking about here. And then I'll give you a quick and dirty. But again, the more I think about this carefully, the better things are going. So we're taking 30%. Any other votes? Cool. So some people are saying 20, some people might say 25, some people saying 30, some people are saying 35. Great, makes me happy. I like the differences of stuff. So what is the brick chunk? What is the difference here between 6 and 8? Just the actual numerical difference. Okay, all right, so that brick is 2. Are we taking a percentage of 6 or are we taking a percentage of 8? Nice, okay, so we're taking a percentage of 6. So in that case, we're taking this chunk of 6. So I'm saying actually the proportion I'm talking about here is 2 out of 6, also known as 1/3. And if you pop that into your calculator, you're going to get 0.33. And the GRE, they love putting that as 33 1/3%. So that's thinking, and thinking I don't want to do on the test. So I see percent increase and decrease, and especially if they say, hey, what is that percent increase or what is that percent decrease? My basic formula for this, my real basic rule of thumb is if I'm talking about change, I want to put change over original. Change over original. Yay. All right. And if you want to continue this out, so do me a favor, type in C divided by O. Do C over O in your calculus. Because I'm going to ask you like 10 times, what is this? So what I would type in the chat window is C over O, change over original. Type that in. Write that down. Change over original, change over original, change over, right. Okay, cool. So in this case, 8 is what percent more than 6. That changes to, and the original amount, which took some ironing out, it took some fighting here, is the original is 6. This is guaranteed, by the way, 30%, 33%, 20%, and 25% are all wrong answers on a multiple choice here. So we want to think about what's the change, what's the original. To make this a little bit easier for us, if we're talking percent increase, percent more, percent greater, a flashcard I would make is change. And in this case, the original on percent increase, more or greater, the change is usually or almost always On percent increase more or greater, your original is the smaller of the two numbers. So you got an understanding, and then park that understanding and just remember percent more, change over smaller. Okay, so change of original is your generic formula. Percent increase more or greater, I just do change over smaller number. Again, you can do x over 100. You can just pop it in your calculator, move some decimals, or whatever you want to do there. So change over smaller number. And in this case, the changes to the smaller number is 6, and I get 1/3. Cool. All right, so let's take a look at the next one. 6 is what percent less than 8? Work it out for me. 6 is what percent less than 8? What do you think it is? So we did percent increase is 2 over 6. Percent decrease. All right, cool. 1 over 4. Jessica, Gianna, follow along with Alex. We got 1 over 4. Perfect. You're going to get it right. Excellent. Well done. Convert that to a percent, though. 25%. Sweet. All right, so change 2. Let me make sure I'm drawing with the right tool. Change 2, but in this case, we're going from 8 to 6, and basically means we're chopping off a portion of the 8, not the 6 this time. So 2 over 8 equals 1 over 4. 1 over 4 equals x over 100 or whatever, but that is basically 25%. Cool. So we've learned something, though, is the GRE loves to manipulate you and manipulate a certain portion of the population into going to the wrong answer. So if I had 8 is what percent more than 6, you'd have 33 and 25 as potential answers. And everything else, 30 and 20%, anything else that anybody guessed. But only 33% is the answer. 6 is what percent less than 8. Everyone, they know certain people are going to mess up, change which one is the original. And so, yeah, 25% is an answer, but wrong answers would be 33%, et cetera. So the test is structured so that a certain portion of the population is going to get certain questions wrong because they have not learned the amazing things you have, which is percent increase is change over smaller, percent decrease is change over the bigger of the two numbers. So I make 3 flashcards. Percent change over original equals x over 100 if you want. But percent increase on the front, on the back, I have change over smaller number. Percent decrease, I have change on the back of the flashcard, I have change over the bigger number. Sweet. So now once we're into this tool of, hey, I know I got a percent change. Were they asking me or are they telling me? So in this case, they're asking me what the percent change is. And on this other page, they're telling me what the percent change is, 20% more, 20% less. So this is where it gets a little tricky, and just a tiny bit of practice can help you. They're asking me, they're telling me. So they're telling me the percent change, they're asking me for the percent change. So this one, they're asking me what percent more, what percent less. This one, they're telling me 20% more, 20% less. Asking, telling. All right, so let's go down and take a look at number 10. This page. So we decided number 11 was a percent change. Are they asking me or are they telling me? The percent change. We know it's a percent change. Number 11, excuse me. Number 11, are they asking me or are they telling me? Cool. Asking. Cool. Nice. So if they're asking me, what am I going to do? Translate or change of original? Cool. Well done. Change over original. So this one is great. 14 is added to 56. So what's the change? Let's just knock this one out. What's the change? Marta, you're way ahead of me. Well done. But let's pop this up. So they're asking me, I'm going to do change over original. So no, you're good. I'm digging it. So 14 is added to 56. What is the change? They told us. 14 is added to 56, so the change is 14. They said so. What's the original number? 56, great. I might muck around with, I can pop that into a calculator right now, 14 divided by 56. I might divide the top and bottom by 7, so I get what, 2 out of 8, yeah? Which is equal 1 out of 4. All right, so what's the percent change? 25%, sweet, okay. Change is 14, original's 56. Wow, there are a lot of traps in there, aren't there? Because like, wait, is it 42 is the change? Is the new number 72? Is that the new number? Is that the old number? So on my scratch paper, I probably would go, I got 56. I would probably write, first of all, 56 plus 14 equals 72. And then I go, what percent? Oh, they're asking me, boom, change of original, increase, cool. And I write on my scratch paper, change over small of the two numbers. So now I've got the change is 14. The smaller of the two numbers is 56. Look, this is not a long problem. So 45 seconds is going to prevent a careless error, where 30 seconds is going to guarantee a careless error. I'll take the extra 15 there. All right, so change 14, smaller number 56. Well done. All right, so this is the tricky part. This is the fun part, and I'm glad you're all digging in on this. This is the stuff I don't have time to do in class always. It makes me very happy. All right, so what about number 13? Are they asking me or are they telling me? Asking. All right, so now I'm going to use change over original. What's the change? Cool, 10. What's the original? 50. Brilliant. Okay, what's that percent? Cool, 20%. Nice, done. Aren't you getting a lot faster? Excellent. Number 14. Are they asking me or are they telling me? Ooh, they're telling me. So remind me the yes, 20, no, 1/5 is 20%. Yes? And the previous one on the previous page is, yeah, 1 out of 14 out of 56 is 1 out of 4, so 25% was this one. Cool. So 25% increase. Cool. All right. So let's go back to this other one here. Eraser. Let's use eraser. There we go. Cool. All right. X is reduced by 30%. So pause there. How do we algebraically translate X is reduced by 30%? And if you can get this, you've just shaved a minute off this problem. Yes. All right. Brilliant. Okay. So everyone gave me some variation of 0.7x is 63. All right, you are getting 165s on the quant section. That is brilliant. That's what you got to do. All right, so 0.7x is 63. Now, if you have a calculator, just do 63 divided by 0.7. Tell me what you get. 63 divided by 0.7. We can do lots of manipulation and calculation. We don't need a calculator for this, but just want to show you 63 divided by 0.7 should be bigger, 90. All right, cool. And if you want, this is a great moment to use exact percentages here. So let's run through this. The value of X is 90. Well, let's test that. What is 10% of 90? So I'm going to do a quick mental check before I move on. So 10% is 9. So 30% would be how much? Would be 27. Cool. 90 minus 27 is 63. Cool. I didn't make a mistake. And X is reduced by 30%. Oh, X should be bigger. If I get something smaller, if I do 30% of 63 and I get something smaller, then I knew I made a mistake. So I've got some visualizations to work with here. Wonderful. One last one, and then we can wrap it up for the day. 75 is reduced by X%. So they asking me, they're telling me. But I don't know what that is. So in a weird way, they're actually doing what? They're saying reduce by X%. Well, they're telling me X%, so I don't know what the damn X is, and my job is to figure out X. So what are they actually doing? Aha, all right, so it's a trap. Admiral Akbar says, all right, 75 produced by X% is 54. So if I wanted to translate that, to be honest with you, it would be kind of a nice nightmare. I would go, 1 minus X% of times 75 equals, times 75 equals 54, and then I'm solving equations for the next 20 minutes. Or, oh, there's an unknown and they're asking me, change of original, let's see if that'll work. What's the change? From 75 to 54, 21, what's the original? Cool, 75. Pop that in your calculators while I'm reducing. Let me reduce the top and bottom by 3. I get 7 over 25. I'm going to multiply the top and bottom by 4. So I'll get 28 out of 100. Cool. So yeah, I don't like calculators. So even though they're more accurate than not. So 28%. Okay. So in a funny way, they're asking me the percent. I could do it algebraically, but why? Why did we multiply by 4? This is just me being kind of slash and burn and lazy. All right, so we said, let me just ask, Jessica asked a question. Why did you just multiply by 4 there? So I got 21 out of 75. So I don't want to pop out my calculator because I personally make more mistakes putting things in calculators. And also I waste more time putting things in calculators, so I don't want to. So I got change 21, original 75. So I don't want to use a calculator. So I look at this and I go, how do I simplify this? How do I reduce this? Oh, they're both divisible by 3. Let me just knock that out. 7 over 25. Okay, so that's my reduction here. Now I got to convert this to a percent. So I could go 7 over 25 equals X over 100 and do some cross multiplication. Or I could remember, what does percent mean? Out of 100. So my question here then is, it's a fraction out of 100. So I've got this fraction here, and percent means per 100. So my question is, what can I do to the top and bottom of this to make the bottom 100? So what do you multiply 25 by to get 100? By 4. So to convert, one little slash and burn tricky way of converting things into percents is, if it's some factor of 100, let me multiply the top and bottom by whatever it is to make that 28 out of 100, and then I get 28%. So for instance, let's say I had 3/20ths came as a result. Again, calculators, just fine. What can I multiply the top and bottom by to make it look like more like a percent? Yeah, okay, multiply the top and bottom by 5 over 5, and I've got myself 15%. It's just a cheap little thing that I do sometimes when I don't feel like popping up my calculator. But I love that question. Back me up. This is what free prep hour is for. You rule. Awesome. These are probably very basic mechanics, but hopefully through translation to percents, and then change of original, you're flexible enough to A, lock in these approaches, and B, choose the right approach for the right question so that I'm not wasting time doing algebra I don't have to do. Oh, can I do change of original on this one? Hey, can I do translation on this one? 1 minus 0.3x, 0.7x. Let me translate that a little bit more quickly. And then I've got a lot more, got a lot easier of a setup, and then therefore a lot easier of a job to set this up. So to solve it from here. So, hey, that's GRE Free Prep Hour with Uncle Neil. So we got some stuff coming up, manhattanprep.com/GRE/classes. You can go there.